We'll now look at different ways to measure angles. And we'll start by discussing the standard position of an angle. When we have our standard coordinate system, and when we're drawing an angle, we want one side to be along the x-axis. And we call this the initial side. The other side can be anywhere else, and we call it the terminal side. And this is what it looks like for an angle to be in standard position. We'll call this angle theta. This angle that I drew here is actually a positive angle because it moves counterclockwise. If I start at the initial and then end at the terminal, we moved counterclockwise. On the other hand, if I draw another coordinate system, and this time I have an angle that looks like this, where I moved clockwise, this one is going to be negative. The initial side is still at the x-axis, and the terminal side is the other side of this angle. There are four basic angle measures that we will consider. The first one is when the initial side and the terminal side correspond. This is 0 degrees. The next are two perpendicular lines. This one will be 90 degrees. If I consider that the initial and terminal edge are in opposite directions along the same line, that would be 180 degrees. And if this time I move down, I have 270 degrees. So these are the four kind of basic places to start with our angle measures. We'll now look at drawing some others, like negative 45 degrees. We know that 45 is halfway between 0 and 90. However, since this is negative, we're going to want to move clockwise. So here is our angle of negative 45 degrees. Next, we'll look at 135 degrees. And once again, we'll have our coordinate system and start still on the x-axis. We know that if I go straight up from here, that's 90 degrees. And to get to 135, I need an extra 45 degrees. So we have this angle here as 135 degrees. We'll do one more, which is 495. We'll have our coordinate system. We'll draw our basic edge, and then we have to think about exactly what's happening here. Around a complete circle is 360 degrees. And for this angle, we still need to go an additional 135 from that. So we'll go fully around the circle, and then an additional 135, which something we've already mapped out. And this will be 495 degrees. When we have a degree of an angle, we can write it in terms of minutes and seconds. So 1 minute, which is abbreviated like this, is 1/60 degrees. 1 second, which this time we have 2, is 160 minutes, or 1/3600 degrees. And so using this, we can now convert between decimals and degrees, minutes, and seconds. This is how an angle is represented. This says 92 degrees, 9 minutes, and 48 seconds. And we're going to convert this to a decimal. The degree is given to us already. A minute is 1 out of 60 degrees. And a second, we would have to divide by the 3600 since we want to convert to degrees. If we try to work this out, we would have 92. 9 over 60 is 0.15. And then for the last part, 48 divided by 3600 is 0.0133. So when I add them up, we would get a total of 92.1633 degrees. For this one, we have an angle that's currently as a decimal that we want to write in terms of minutes and degrees. First off, we already know it's 39 degrees and we only need to find the minutes and seconds, and that's going to come from this decimal. When we went the other way, we divided by 60, so now we will multiply by 60. And so we have 0.754 times 60 is 45.24. And once again, we take the whole number part of this, and that's going to be the number of minutes. Taking the decimal part and multiplying by 60 again gives us 14.4. And that tells us our seconds. We have 14.4 seconds. Next, we'll talk about the central angle. So let's suppose we have this circle and it's of radius r. Well, if I have an angle that intersects this circle, this is called a central angle. The main thing is the vertex of the angle should be at the vertex of the circle. And we intersect this little piece right here. And the idea of doing this is if we have a circle of radius r, and this length of this arc that we intersected is r, then the measure of the angle is 1 radians. And this is another way to measure circles and angles in particular. We would like to convert between degrees and radians to see that relationship. And we can actually say that 1 degree is pi over 180 degrees radians. And on the other side of that, 1 radian is 180 over pi degrees. So now we have a way to convert between the two. If I want to convert 30 degrees to radians, I would need to multiply by pi over 180. 30 divided by 180 is 1/6, so this is pi over 6 radians. For 120 degrees, we would do 120 times pi over 180. And 120 over 180 is 2/3, so this is 2 pi over 3. Negative 90 degrees. This time I would multiply 90 by pi over 180. And 90 over 180 is 1/2, so pi over 2. We could also do negative 45, or positive 45 rather. 45 degrees. Once again, multiplying by pi over 180. And 45 over 180 actually gives us 1/4. So we have pi over 4. And we'll do one more and look at 103 degrees. Well, multiplying 103 times pi over 180, 103 over 180 actually doesn't reduce, so we just get 103 pi over 180. Finally, let's look at going the other way. I have pi over 3, and if I want to convert to degrees, I will multiply by 180 over pi. 180 divided by 3 is 60. If I want to do 3 pi over 4, well, multiplying that by 180 over pi, we would have to do 180 times 3, which is 540, divided by 4 is 135. Minus 3 pi over 2. Well, if I multiply this by 180 over pi, negative 3 times 180 is negative 540, divided by 2 gives me negative 270. 8 pi over 3, multiplying this by 180 over pi, well, we would have to do 180 times 8 divided by 3 to get 480 degrees. Finally, what if we just had 4 radians? Well, we multiply that by 180 over pi, and 4 times 180 is 720. So 4 radians is 720 over pi degrees.